Today we are going to keep going with our calculations in chemistry. And we're here in our quantities in chemistry unit. I just want to bring your attention to the main page here. You probably noticed this already, but the company that sets up your resources for this course, they list all the learning activities here on this main page. And these correspond to those main resource notes that we go through. Okay, so you can go along and you can see what we're going to be covering. Now, we do several lessons in each of these resource notes. So in 3.1, we actually are going to do, well, 4 lessons. The 5th one will be kind of tying everything up. And so we do have a lot of little lessons that we're going to be doing in this unit. And it is all math-based, okay? You can also see what's coming in terms of the culminating project, okay? So we've talked about that at the end of each of these units, we're going to do a little project worth 5% of your final grade, okay? So none of these will be released to you or, your marks will not be given back to you until towards the end of June. But these have to be done. They are part of the final 30% of your mark. And this one's going to be on a careers in chemistry project. So we've been making our way, if we look over here in content, working our way down with these lessons. And today we are focusing on moles, but also incorporating mass and molar mass. So we click on what do I do? And the first thing I am advising everybody is to get their periodic table handy, okay? This periodic table is given, if we go back over here to the menu of content, it was provided to you back at the very beginning of the course. We need it now, okay? It is really important that you have that, and you really should print that off and have that beside you so that you can reference all the elements on the periodic table and how much each of them weigh. So we've spent some time going through atomic mass, average atomic mass, and isotopes, and we understand how these masses on the periodic table come to be. So when I look at something like silicon, for example, or phosphorus, we notice they are not whole numbers. There's very few on the periodic table that are whole numbers. And we understand now that the reason that they're not whole numbers is because there are these different versions of each element called an isotope. And each of those versions exist with a different percentage value on Earth. And these are, weighted averages based on the percentage value of each of those isotopes. So the isotope or the mass of the element kind of favors whichever isotope is in the highest proportion. Now, if you look at the periodic table and the legend over here, there's atomic number in the corner, there's ion charge, there's the name. And then down here, the very last number that's listed, it's called molar mass. And notice the unit, grams per mole. So this becomes a really important number to us now, like very, very important as we go through and we do our calculations. So we've been calling these masses on the periodic table atomic mass units. And now we're going to switch over to a different unit, which is more accurate, because we now understand the concept of a mole. Okay, so 1 mole is 6.02 times 10 to the 23 particles. And so now if you have a mole of something, this will be the molar mass that your element weighs. So if I had 6.02 times 10 to the 23 atoms of hydrogen, it should weigh 1.01 grams on the scale. So what we're going to do is we're going to take you through the main resource note. So we're going to go back here to what do I do? And I have here the summary note for you. We'll reference that in a second. And then the main resource note. So we're still working our way through that main resource note. The summary note that I have for you, again, I'm encouraging you to print off the periodic table. But this note today is going to focus on mass and moles. And so we have to understand this concept of the molar mass. So what's the definition of it? What unit is it expressed in? Well, I just went over that with you. But you can go into your main resource note and you can find that work in the main resource note here while we wait for it to load. And then you're going to scroll through and you're going to find where lesson 7 begins. Okay, so here it is. So we just scroll down and we go to lesson 7, lesson 4. And my Chromebook is not enjoying me at the moment. Here it comes. There's a bit of a delay. Okay. So this is particles, what we did yesterday. So here's lesson 4. And again, I want you to read through this. I know I go over things very briefly here in my videos, but you have to read through this, answer the questions, and understand that now the atomic mass is the mass in grams per mole of substance. So a mole is 6.02 times 10 to the 23 particles. That's how much that substance should weigh. So let's practice finding the molar mass of an element and of compounds as well. Okay, so right here. So these examples I'm going to take you through in your summary note, but I'm also going to do this here in on a Jamboard with you. Okay, so we're going to just click over here and we're going to answer this question. So what is the molar mass of sodium? Well, this is a very simple question. Okay, so what we're going to do is we are going to just simply go to the periodic table, and then you find where sodium is. There it is right there. Okay, and you look up the atomic mass of it. So it's 22.99. And this is what I write, is that it is 22.99 grams per mole. Okay, that's what it weighs if I had 1 mole of it. What is the molar mass of oxygen? So again, you need your periodic table. This is why you have to print it off, folks. Have it right beside you. Find oxygen. Here he is right here. Oxygen's molar mass. So if I had 1 mole of oxygen atoms, it would weigh 16 grams per mole. Okay, so easy. You just go and you find it off the periodic table. Now, when you get into compounds, it's the same idea, but it's just a little bit different. You have to add up the molar masses. Okay, so we're just going to make a note here. We're going to add the molar masses in compounds. So if I have H2O, what I want to do is I want to add up my hydrogens and I want to add up my oxygen, but I also have to be aware that I might have more than 1 atom present. So in an H2O formula, I actually have 2 hydrogens. So I have to multiply the molar mass of hydrogen by 2. We go over to the periodic table. What is the molar mass of hydrogen? Here he is right here, 101. So I have to say that there's 2 atoms of hydrogen times 101 grams per mole. And then I add on the molar mass of oxygen. And I only have 1 oxygen. So we just did oxygen above. We can just say plus 16 grams per mole. And this gives me a total of 18.02 grams per mole. Okay, so you have to just add up your elements, but you also have to take into account that there may be more than 1 of them. And if there are, you just multiply by the number of atoms to your molar mass. Now, here comes a big compound. This is calcium phosphate. And same thing, I got to add up all of these elements. So I have an element of calcium, but I have 3 of them. I have 1 phosphorus. I have 4 oxygens. But this is a polyatomic ion, and I have 2 of those polyatomic ions. So I have to take into account all of these little details when I come up with my molar mass. So we're going to start here, and let's start with calcium. Okay, I have 3 calcium atoms. So I'm going to write 3 times the molar mass of calcium. So we got to go to the periodic table. Here's calcium right here, 40.08. Where am I here? Jamboard. So 3 times 40.08 grams per mole. And then I'm going to add on my phosphoruses. So I have 2 phosphorus. okay? Because there's a 2 outside of that bracket. So I want to look up what the phosphorus will weigh, and keep in mind that I have 2 atoms of it because of that bracket and because of the 2 outside. So phosphorus weighs 30.97. So I'm going to come back, and say that I have 2 of those times its molar mass of 30.97 grams per mole. And now I look at oxygen, okay? So for oxygen, there are 4 oxygens in the formula of a phosphate, but then I have 2 phosphates. So I actually have 8 oxygen atoms, okay? Not 6, I have 8 of them. So I have 8 oxygens times what the molar mass will be, which is 16 grams per mole. So be careful here when you have a complex compound, okay? You got to make sure that you're multiplying by the numbers of atoms. And sometimes you have to expand the atoms like we saw right here with that phosphate. So careful with your math now as you go through and you multiply everything together and then add it up. So if you want, you can do baby steps. Okay, there's nothing wrong with that. So let's do 3 times 40.08. We get 120 that's a 0.24 grams per mole. We're going to add on, we don't want an equals, we want an add. So we're going to add on 2 times 30.97 for phosphorus. This equals 61.94 grams per mole. And then we're going to add on 8 oxygen atoms. So 8 times 16 equals 128 grams per mole. And then we add everything up. So careful with your calculator here as you add everything. And I'll tell you what I get in a second. I'm getting a total molar mass of 310.18 grams per mole. Okay, so hopefully this makes sense to you. And again, molar masses are pretty easy. You have to have the periodic table beside you. You got to add them up. And remember, you may have more than one atom, and you have to account for that as you go through the molar mass. So as we go through our resource note, we just went through these examples of molar masses. And now we're going to get you to practice there with molar mass in the summary note. You'll fill that in. I made a chart for you. And then ignore that lesson 5. That's wrong. That shouldn't be there. We now are going to try to deal with what happens when, again, I don't have exactly 1 mole of a compound. What happens when I have 2 moles? How much would a substance weigh? Or what if I had half of a mole? How much would a substance weigh? And conversely, what if I didn't have the molar mass of a substance? So we know oxygen is 16 grams per mole. Well, what if I had 32 grams per mole? What if I had 100 grams of oxygen? How many moles would I get? So you can convert things back and forth. And here is our formula that we're going to use. So I'm just going to come back to the Jamboard here, and I want to talk about the formula that we use to convert between moles and mass. To do this, we set up a formula that looks like this now. Okay, so we've seen the one formula that we used the other day had all these N's in it. And this is a good formula. We're going to come back to it, but this is for particles. Today, we're going to start to talk about mass. So we still have little n, which is moles, and has the unit of mole. Now we're going to notice that we have a lowercase m, which stands for mass and has a unit of grams. And then here in the denominator, this is my constant. This is my molar mass value. Okay, and molar mass is in grams per mole. Now I use a scripted m like that. You can use a scripted m. You could use 2 m's for molar mass. Either way is totally fine. But just notice here what's happening, right? You guys will always know the molar mass, okay? So we're going to write here, you can calculate this, Okay, they are not going to give you the molar mass of anything because they know you can look that up on the periodic table. And from there, they're going to ask you maybe what are the moles of a substance? What's the actual mass? Okay, this is actual mass of an element or a compound, and get you to calculate and convert. So as you move your way down the resource note, you're going to notice that there are a couple of examples that we can go through. So I'm going to go through the two examples with you together here. So here's an example where we have a compound, SO2, and it says how many moles of SO2 are contained in a 3.56 gram sample. So what do we know? We don't know our mole value. Okay, they're going to ask us to solve for that. We know our little m, lowercase m, which is actual mass, and we know that that is 3.56 grams. Now, notice what is happening here. They have not given us the molar mass of SO2. And again, they're not going to, because they know that you can go onto the periodic table and you can calculate that yourself. So I'm going to set this up right here. So molar mass of SO2, I better solve for that. So we head over to the periodic table and take a look at our formula. We need 1 sulfur and 2 oxygens. So sulfur and oxygen are very close on the periodic table. Here they are right here. 1 sulfur is 3207, 1 oxygen is 16, and we have to account for the fact that there's 2 oxygens in the compound. So we're going to take 32.07 grams per mole, and we're going to add on 2 times 16 grams per mole, and we're going to come up with that molar mass of SO2. Okay, so again, they are not going to give that to you. They know that you can calculate that yourself. And the molar mass is 64.07 grams per mole. Now, let's solve for moles. Okay, we know what our formula is, right? So we looked at that the first Jamboard. Here is my formula when I am dealing with masses. So they're asking us to solve for moles. We know mass. We just calculated molar mass. We'll be able to set this up and solve for the number of moles. So moles of SO2 equals mass divided by the molar mass. Okay, and this is how you should set up your formulas, folks. You should tell me what are you solving for in brackets. I need to see the actual mathematical formula. I need to see your in-between steps. So 3.56 grams divided by 64.07 grams per mole. And take a look at these numbers, right? 1 mole, right? This is what this unit means here. 1 mole will weigh 64.07 grams. I'm nowhere near there. Okay, I got way less than 64 grams. So I already know I'm going to have a mole value that will be small. Okay, it'll be less than 1. And we're going to account for that. So let's do the math. 3.56, we divide that by 64.07. And we get an answer of 0.0. Then I have a whole list of 5s, okay? So I want you to go to 2 decimal places normally, but in a case like this where I have a leading 0, I'm going to go 5, 6, like that, okay? So that's 3 decimal places, but this is 2 non-zero digits, okay? And that's what I would want you to report to in this case. Okay, so again, we're just using our new formula. We're looking up a molar mass, and then we can solve for the number of moles. Here's another example. It says a flask contains 0.750 moles of CO2. What mass of carbon dioxide is in the sample? So we know that my mole value is close to 1, okay, but not exactly. So it's 0.750 moles, 3/4 of a mole. They're asking us to solve for the actual mass of CO2, okay? That's what they're asking for. And we know that our formula here that we're going to use to calculate moles of CO2 is equal to mass divided by molar mass. And we know they're not going to give us molar mass. We can calculate that. So we're going to need to. So let's calculate the molar mass of CO2. And let's do it right now. And then we'll rearrange our formula and solve for what we need to here. So we go over to the periodic table. There's oxygen again. You're probably already knowing oxygen's molar mass is 16 times 2. But we also need to add on the molar mass of carbon. So we go, and here's carbon right here, 1201. Okay, so we'll add all that up. So carbon is 12.01 grams per mole. Maybe I'll add this way. Let's add this way. Plus 16 grams per mole. And then one more, right? Because there's 2 oxygens. So 16 grams per mole. Different ways that you can set up math. As long as you get the right answer. That's all we care about. So 1201 plus 16 equals 44.01 grams per mole. Okay. So we've been asked to solve for mass. That's what we need. So what we're going to do is we're going to take this molar mass and we're going to cross multiply it up and over times my mole value. Okay, so let's set this up. We're solving for the mass of CO2, and we're going to take moles times the molar mass of CO2. So 0.750 mole, not quite 1 mole. And we're going to multiply that. I'm going to run out of room. I'm going to put it here, 44.01 grams per mole. Okay, so I expect this mass to be just under 44 because 44 grams would be 1 mole. And I don't have 1 mole, I have 0.75. So we're going to multiply those two together. And I'm getting a mass of 33.01 when I round that number grams. Okay, so there's a couple of examples for you using this new formula, okay, and this concept of molar mass, okay, so a couple of new ideas here. And if you go back to the summary note, we just did these examples together, okay, so we did these examples together here in number 2. You're going to try these ones on your own. I just did these 2 examples, 2 and 3. You're going to answer everything else, and you're going to try your luck at all these examples as well right here. Okay, good luck and be in touch if you have any questions.